Hey guys, Mr. Yisley here. So we're on to lesson number 13, and we're talking all about how to graph these functions in the form of f of x equals a times x minus h squared plus k. Reminder that that's known as vertex form of a quadratic function. So when we're looking at them in vertex form, I think that kind of the first thing we want to do is identify what's our a, what's our h, and what's our k. Now remember, a is always found in front of the parentheses, so in this case it would be the -2, so that would be my a. K is always found inside, right, of the parentheses, so it would look like it's a +2, but remember that h always works in reverse, and I can't remember if I accidentally just said k, but I meant h. The h is always found inside the parentheses, and it always works in the reverse. So though it looks like a +2, it's really a -2. And then our last one we want to make sure we find is our k, which is always at the end here, and in this case it is the +3. All right, so now in order to be able to graph these, the first thing we want to do, as we talked about on how to graph, is graph the axis of symmetry. So we need to know what is the axis of symmetry so that we can graph it. Now the axis of symmetry here is always going to be x equals h, remembering that h works as an opposite. So what I have is x equals, my h was +2, so that really means -2. So x equals -2. So I'm going to go in and I'm going to graph that line. So at -2, so 1 to the left, 2, and I'm going to draw my little dashed line that gives me my easy way to mirror points from one side to the other. So there is my dashed line. After we've done that, then we want to go and find the vertex. All right? Now remember, we find the vertex because the vertex is always going to be h comma k, remembering that h works opposite and k works the way it should. So my h in this case was +2, so again that makes that -2. My k was +3, and k's work exactly as they should, so this would be -2 comma 3. So that's important to remember. Now I know on your steps it says go ahead and plot that vertex. We're going to hold off a second, and the reason for that is the next step is then we're going to choose two x values, plug them in, and figure out where they're at on that. And the reason we're going to hold off is because just in case we have to relabel our graph, then we don't have to move the vertex. So we won't plot the vertex until we know that the graph as it is doesn't need to be relabeled. So let's move on to step 3, which is to choose two x values. Now I'm always going to tell you to choose two numbers that are immediately to the right of that, unless you see some fractions in there for a, right? This is not a fraction, it's a whole number. So I'm going to choose one to the right of -2, which would be -1, and I'm going to plug that in. So what I've got is g of -1 is equal to -2 times -1 plus 2 all squared and then plus 3. Then I got to follow the PEMDAS order. Well, PEMDAS says parentheses first, so I need to simplify inside my parentheses. So I've got -2 times -1 plus 2 is 1, and then that's squared plus 3. So then I need to move on to my e, which is exponent, so I need to do my exponent. So I've got -2 times 1 squared is 1, and then plus 3. Then I can move on to my multiplication division. I have multiplication, so I've got -2 times 1, which is -2, and then plus 3. And then last step, addition and subtraction. -2 plus 3 is +1. So my order pair for that point would be -1, comma 1. And then I need to follow that exact same process for the next point. And so I would choose one to the right of that even, which would be 0. So I'm going to plug in 0 now. So g of 0 equals -2 times 0 plus 2 squared plus 3. And then I need to solve it. So again, starting with parentheses, 0 plus 2 is 2. So -2 times 2 squared plus 3. Then my exponent, So I've got negative 2 times 2 squared, which is 4, and then plus 3. Then negative 2 times 4 is negative 8 plus 3, and then negative 8 plus 3 is negative 5. So my next order pair would be 0, negative 5. Now as I look at these, all these values are less than 10, so I don't need to do any relabeling. So now I'm going to go in and I'm going to plot those 3 points. The vertex, the point to the right that I found, and the point to the right of that I found. So negative 2, 3 says go left 2 and up 1, 2, 3. So there we go. There's my vertex of my parabola. Then negative 1, 1 says go left 1 and up 1. And then 0, negative 5 says don't move left or right, but move down 1, 2, 3, 4, 5. And there is that point. Now remember, that's only half your parabola, so step 4 is we need to mirror these 2 points to the other side. So this point was 1 to the right of the axis of symmetry, so I'm going to go 1 to the left and stay even with it. This point was 2 to the right of the axis of symmetry, so I'm going to go 2 to the left of it and stay even with it. And there we go. I've got my 5 total points of my parabola. So now I'm going to graph that parabola. So draw my smooth curve as best I can, arrows at each end. And then last step is we need to compare that graph to the graph of f of x equals x squared. So first thing we're going to compare here again is the a. So a was a 2, because remember the negative isn't a part of it, so a was 2 and 2 is greater than 1, so this was a vertical stretch by 2. And then second thing we're going to do is reflection, which again is determined by a negative. Well, we did have a negative, so that means we had a reflection, and reflections with parabolas always happen across the x-axis. Third thing we're going to look at is my vertical shift. So my k, I did have a k, it was positive 3, so that means I had a vertical shift up by 3. And then last thing we look at is the h, that's horizontal. All right, I did have an h, it was positive 2, but remembering h's work in reverse, or the opposite. So instead of positive 2, it was negative 2, and negative 2 is a move to the left. So we had a horizontal shift left by 2. All right, and that is how we graph the quadratic functions in vertex form. That is how we describe the comparisons. All right, well, if you want to flip your paper over, we're going to move on to example B here. So example B, exact same process, so we're going to practice through that process again. So again, I think a helpful thing to do is to start by figuring out your A, your H, and your K. And my A in this case is this negative 3 right here. My H is the positive 2 inside of here, but remembering H's work is opposites. And then my K is this positive 2 here at the end. So again, my A is the number out in front of the parenthesis. My H is inside the parenthesis. It works as an opposite. And my K is at the end of the parenthesis. All right, so first thing we need to do is figure out our axis of symmetry. So a reminder, axis of symmetry is found by x equals h, and it's always the opposite of h. So I know that this is x equals, this was positive 2, so that means it is negative 2. So I'm going to come over here to my axis, and draw my axis of symmetry, so that little dashed line that makes everything the same from one side to the other. So I've got that drawn. Then I want to find my vertex. Now reminder, vertex is h comma k. So h works as in opposite, so that means that's negative 2. My k is positive 2. So vertex is negative 2, 2. Now again, reminder, before we plot that point, let's make sure that we can fit our graph on as is. So let's figure out our other 2 points. Well, again, I'm going to choose a point to the right of axis of symmetry. So to the right of -2 would be -1. I'm going to plug that in and see, does it come true? So I've got g of -1 equals -3 times -1 plus 2 squared plus 2. And I'm going to solve that down. So first thing, simplify inside parentheses. So -3 times -1 plus 2 is 1 squared plus 2. Then I do the next one, right? So, which is my exponent, so 1 squared. So -3 times 1 squared is 1 plus 2. And then I do my multiplication, so -3 times 1 is -3, and then plus 2. And -3 plus 2 is -1. So my point there is -1, comma, -1. My x was -1, my output was -1 as well. So then I need to choose another point to the right. And so after -1 is 0, so I'm going to use that. So g of 0 equals -3 times 0 plus 2 squared plus 2. So again, simplify inside parentheses. So I've got -3 times 0 plus 2 is 2 squared plus 2. Then my exponent, 2 squared. So -3 times 2 squared is 4 plus 2. Then my multiplication, -3 times 4 is -12, and then plus 2. And then last addition, -12 plus 2 is -10. And so my order pair for this would be 0, comma, -10. And so I can fit that on my graph, just barely. So I'm going to go in and graph those 3 points that I have. So vertex of -2, 2, that says go left 2 and up 1, 2. So there is my vertex on the axis of symmetry. The point -1, -1, that tells me to go left 1 and down 1. The point 0, -10 says don't move left or right from the origin, but move down 10. And there is that point. So now that I've got that drawn, now I need to mirror these 2 points across. So again, this one was 1 to the right, so I need to go 1 to the left of the axis of symmetry and stay even with that point. Same thing on the bottom one. That was 2 to the right of the axis of symmetry, so I need to go 2 to the left of the axis of symmetry and stay even with that point. So now I've got my parabola, so I need to draw that. So I'm going to draw as smooth a curve as I possibly can. Arrows at each end. So then last thing we need to do now is we need to do the comparison. So number 1, we deal with the A's, and A's tell us vertical stretch or shrink. Do we have an A? Yes, we do. It's a 3. We don't worry about the negative. So 3 is bigger than 1, so that means we have a vertical stretch by 3. Second thing we look for is reflection. Reflection's determined by negatives in front of A. We have a reflection. So this is a reflection across the x-axis. We can also look at our graph and see that it's pointing downwards. So that tells us that there's a reflection. Third thing we're looking at is K. Do we have a K? Yes, we do. It's positive. So that means we had a vertical shift up, because it's positive, by 2. And then last thing we look for is H, remembering that H's work as opposites or in reverse. So instead of being positive 2, it was a negative 2, and negative 2 is a horizontal shift left. So we had a horizontal shift left by 2. And there we go, we've graphed our function and we've described the comparison between it and the parent function of f of x equals x squared. All right, well, I would encourage you to try example C and example D on your own, and then click over to the next video, the second part of lesson number 13 here, and check your answers to see if it is correct.